name is Ilya, and today I'd like to show you my C++ order book that I've created. So I will break this into three sections. First, what an order book is really briefly. Then I will show you a demo of how mine works. And finally, I'll talk about how I designed the book from a programming perspective. So if you don't know, an order book is just a list of orders for any financial security. Um, it lists buyers and sellers who are willing to buy and sell at different prices and different quantities. And so an example of this would be Apple on the NASDAQ. So Apple on the NASDAQ, it trades, it has buyers and sellers at any given moment willing to buy and sell at different prices and quantities, and the order book is just tracking all of that. So every financial security, every stock on the NASDAQ will have its own order book. And that's what I've wanted to emulate with this project today. So let's move on to the actual demo. I will begin by compiling and running my program. So we are greeted with a screen here, which allows us to print and submit orders. So let's first print the order book. Okay, so this is a visualization I've made of an order book. Um, you can see up here we in the red have all the asks, how much people are willing to sell for. Here in the green, we have how much people are willing to buy for. And we see that for every price level, so this is $108.46, 138 units are available to be bought. So people are offering 138, if this is say Apple, for example, 138 shares of Apple at at this price level. And you can see all these different price levels with all these different quantities. Now, one thing I added was this visualization of the quantity because it's a little hard to look at just the numbers. So the visualization kind of helps to show you where the size is, where the quantity is. And then we also have the bid ask spread here, which is just the difference between the best offer and the best bid. So this is 2%, 2.06%. And now I'd like to show you how the actual execution of orders works in this book. So let's submit an order. Let's make it a market order, which just means that we don't care about the price that we transact at as long as it's the best price. And let's do a buy. Let's buy 30 units. All right, so it looks like we were filled for all 30 units at this average price, and it took 12,000 nanoseconds, which is 0.012 milliseconds. Pretty fast because it's C++. Now, what do we expect to see? We bought 30 with a market order, so it will transact at this price level. It's the best one. And we expect the quantity to go down by 30. Now, let's see if that's what we observe. It is. The quantity went down to 106, which is fantastic. So the order got executed, we got matched, and now let's do limit orders. So a limit order, now we do care about the price we get executed. It gives a cap at how much we're willing to buy or sell for. So limit order, in this case, in this time, let's do a sell order just to show you how that works. And let's do a quantity of 100. And the minimum I'm willing to accept, say, is, I don't know, $96. So you can see we were partially filled this time, not fully, at an average price of this, and it took 42,000 nanoseconds. So what do we expect to have happened? Well, we put in an order for 100. We got partially executed at I need 886, which would be here. So since we submitted it for greater than 39 units, that means we wiped this whole level. So this level will be gone from the order book. But of course, we weren't filled all the way. So what's left with the other units? Well, they're placed as a standing sell order, standing sell limit order at the price that we are minimum willing to accept, which is $96. So let's print the order book and see if that's what we observe. It is. We see that the leftover quantity here is at $96. That's our leftover order, and we see that the price level here has been wiped, the one that we fully bought. And yeah, so that's kind of how it works. It does market limit orders as you saw, and it has this nice visualization. And so now I'd like to show you and talk about how I designed this project a little bit. So the project is broken down into three main parts. There's a main, which deals with the interaction with the user. So this is where you enter all of the stuff into the terminal, and the program decides what to do and make all the calls and stuff. And the next part is the order um, class. And this just represents an order. It has some properties about it. And this will be helpful in our next class, which is the order book class. And the order book class is going to hold and deal with and work with order objects. So I will now talk about very briefly how this order book class is designed, because this is really the bread and butter. It holds two hash maps, one for the bids and one for the asks. And it holds hash maps of um, the price level as the key, and the value is a vector of orders. And we have a bunch of functions to work with this. So we have add order, which adds the order, adds an order to the book. So it'll add it to these hash maps. And we have an execute order, which is how we there's an algorithm here to execute orders against the book. And if you don't get executed, your order gets placed as a standing limit order into the book. And we have some minor helper functions, printing and that sort of stuff. Best quote gets the best quote, print prints the visualization. And one thing I'd just like to point out is that this is a FIFO execution algo. So um, if you are able to transact, you will transact against people who were there at that price level first. So that's how it works. We have this timestamp here, and it sorts basically at every price level the orders by timestamp, and it executes them in order. So that's all that it means by a FIFO execution algorithm. And yeah, that's kind of the project. If you want to know any more details about how I implemented it, you can read the code or ask me. But thank you so much for watching, and have a great day.